To increase the rate of innovation, then life can become multiplanetary. This is the goal we should strive for.
Starbase looks different today. A thick forest of metal rises from the ground. Heavy steel beams reach high into the air. This is the gigabay taking shape. You can feel the change happening. It is not just a building, it is a machine designed to make rockets fast. You've seen sites like this before. They are usually loud and dusty, but this one feels different. The steel is not spread out across a wide field. It is stacked tight. It goes floor on top of floor. It rises column on top of column. The shape is already clear to anyone watching. It is tall, it is dense, it is purpose-built. This is not just a warehouse for parts. This is a machine for building the largest rockets in history, and it is rising faster than anyone expected. Early January 2026 photos showed the first big change. 3 full levels of columns were already up. These were not just outlines or sketches. This was a real structure. You could see the thick steel and the bolted joints. Wide beams were already locked in place. From some angles, you could see right through it. It looked like a giant jungle gym made of iron. From other angles, it already looked like a finished building. That switch in how it looks matters. Once the steel goes vertical, the clock changes for the whole program. This is where things get interesting. The gigabay is planned to reach about 380 feet tall. That is taller than a 30-story building in a major city. That height is not just for looks. Since Starship rockets are very tall, they stand about 400 feet. When they are stacked with the booster, they do not fit in normal buildings. They never have. That problem has slowed down every big rocket program before this one. You cannot build fast if you cannot stand the rockets up inside. Think about that for a second. If you cannot lift a full rocket inside, you have to build it in pieces. You have to roll those pieces outside. Then you have to wait on the weather. You move slow because wind or rain can ruin the work. You lose days, sometimes you lose weeks. That is how it has always been done in the space business, and that is why big rockets have always taken years between flights. It is meant to hold many rockets at once. It is not for 1 or 2 ships. About 24 work spots are planned inside this one building. That means engines can go into one ship while heat tiles go on another. Wiring can happen on a 3rd ship at the same time. Lifts will be running and cranes will be moving. All of this happens under one roof. All of it happens at the exact same time. You already know why that matters. More indoor space means more build speed. More build speed means more rockets. More rockets mean more launches, and more launches change the whole future of space. But none of that happens if the building itself stalls out. And that is the part where many other projects, big buildings often drag on for years. You see it with airports and stadiums. You see it with simple road jobs. Steel goes up slow and then it stops. The site sits empty for months. That has not happened here. From January 7 through January 15, new video kept coming in. Every update showed more steel and more floors. The height kept growing. Cranes were moved higher. Elevators were being installed already. They did not wait for the end. Temporary lifts were already running up the sides of the frame. Workers were already walking on the 2nd and 3rd levels. That tells you the team is not waiting for the shell to be finished. They are building the system as they go. You could see thousands of bolts stacked on platforms. These are real fasteners. They are thick bolts driven by heavy tools. That detail matters more than you might think. Bolted steel goes up much faster than welded steel. It also makes it easier to change things. You can move beams if you need to. You can add supports or shift the plans. Welds and rivets lock things in forever. Bolts let you adapt as you learn. That is a sign this building is still evolving. It is built to change because the rockets change. This structure is not just tall, it is custom. Every column is spaced perfectly for the cranes. Every beam lines up with the work bays. Every floor is planned around rocket work. The doors are not office doors. They are wide and tall. They are built for moving sections the size of houses. Nobody talks about this part. Buildings like this usually fail fail because stuff cannot move easily. People get stuck and cranes block each other. Work piles up in the corners. The gigabay steel layout shows they learned from those mistakes. It has open cores and wide spans. It has clear vertical paths for lifting. It is built like a factory first. It is not built like a standard office building. That decision led directly to the speed we see today. Crews can work on multiple levels at once. One team sets the columns while another bolts the beams. Another team builds the stairs. Another runs the pipes at ground level. Photos showed insulated lines already being laid. These carry water and air and power. These are the things the machines need to breathe. They did not wait for the roof to start the guts. This is where a pattern starts to show up. Every big build at this site has followed this same rhythm. First, the dirt moves, then the tanks appear, then the steel goes vertical, then the work explodes. You saw it with the launch tower and the engine shop. You saw it with the first high bay. The slow part is always the start, the fast part is the middle. Gigabay is now in the fast part. 3 column levels done in 2 weeks is not slow. That is a massive amount of work, and the roof sections have not even started yet. That means the vertical pace can still go up. Here's the problem they are solving. A Starship is not a small thing. Each booster stands about 230 feet. Each ship adds another 160 feet. Together they pass 390 feet. You cannot tip these over easily. You cannot move them very far once they are stacked. Weather becomes your enemy the moment you step outside. Wind becomes your boss. That has killed more rocket schedules than engine problems ever did. The Gigabay removes that choke point. It is tall enough to stack them inside, it is wide enough to hold many of them, it is strong enough to lift full sections, and it is dense enough to run like a factory instead of a construction site. That sounds simple, but it is very hard. Steel at this scale actually bends. It moves when it gets hot in the sun. It shifts under a heavy load. Every crane adds a new force to the frame. Every lift adds a little bit of sway. And rockets do not like sway. The structure has to be very stiff. That means it needs a lot of bracing. You can see it in the photos. There are cross beams everywhere. Diagonals tie the columns together. There are frames within frames. It looks busy because it has to be. Engineers did not choose that look for fun. Physics chose it for them. Another thing that stands out is the cranes. There is not just one crane. There are several, and they are not light cranes. These are tower cranes. They are the kind used for building downtown high-rises. Their bases are anchored deep near the core. Their arms sweep wide across the site. That tells you how heavy these beams are. It also tells you how heavy the future loads will be. You do not put that class of crane up unless you plan to lift very heavy things, and you plan to do it over and over. If the cranes are busy, the workers have to wait. If you have many cranes, the work flows. The Gigabay layout shows crane coverage across the whole footprint. That means beams can go up in parallel. Floors can fill in faster. Later on, rocket sections can move without getting stuck in a line. Here is what failed before. Earlier bays were smaller. They worked for a while, but they hit a limit. Only so many rockets could fit inside. Only so many could be stacked at once. When the flight pace picked up, those buildings became the limit. It was not the engines or the fuel. It was the space. That is the wall they hit. You cannot raise the build rate without more space. You cannot create space without massive steel. And massive steel usually takes years to build. The Gigabay is moving in months. That did not happen by accident. The steel design itself is part of the breakthrough. Instead of heavy solid walls, the early frame is open. That lets the wind pass through. That means the cranes do not have to shut down as often on windy days. That alone can add weeks of work every year. It also lets the crews see everything. They can check the alignment from far away. Mistakes get caught early before they become big problems. Rework is what kills schedules. Bolted joints also help here. Crews can set a beam and check if it is level. Then they tighten it down. If a column drifts a little, they can adjust it. That flexibility is what creates speed. Old builds lock in too too early and then they pay for it later. Another reveal was the stairs. They put in real stairs early. These are not just ladders, they are multi-level stair towers. That means they planned for hundreds of people to move up and down every hour. You do not add those early unless you expect a huge crowd of workers. And that is the scale here. Hundreds of people per shift, multiple shifts around the clock. You cannot run that kind of operation on lifts alone. You need clear walking paths. And they are already there. 3 months ago, this site was just dirt and piles of gravel. Now it is a steel maze. Let that sink in for a moment. Because of this speed, other work can move forward. Ship 39 scaffolding went up nearby. Engine sections continued to grow. None of that matters if the finished ships have nowhere to go. The gigabay is that place. It is the sink that allows the whole system to flow. Here's the competitive part. Other rocket programs build tall buildings too, but they do not build them like this. Most are sized for only one rocket. Maybe they can hold two. Most are meant for only one specific job. They stack or they test or they store. The gigabay is meant to do all of it. It does it many times at once. That changes the cost. If you build one rocket at a time, every crane hour costs more. Every crew has to wait for their turn. Every weather delay hits the whole company. If you build 10 at a time, the delays spread out. The cranes stay busy. The crews stay moving. The cost per rocket drops. That is resource efficiency you can actually feel. There is also a timeline effect. If one ship has a problem, the other 9 do not have to stop. The work just shifts to another. The building stays productive every hour of the day. That is how car plants work. That is how airplane plants work. Rockets never worked that way before. They were always built one at a time like a custom piece of art. The gigabay is built to end that era. You see this in the floor layout. There are open bays with no walls between them. It looks like a pit lane in racing. You can move from one ship to the next in seconds. You can share tools and share parts. The result is a building that grows while others are still doing paperwork. Here's how they actually did it. The breakthrough was not a new gadget. It was an industrial shift. It was the ability to raise a 380-foot factory fast enough to matter. This has blocked space progress for 50 years. Big rockets existed in the past, but big factories for those rockets did not exist. Now one does. Victory validation will not come from a press release. It will come from the numbers. It will come from how many ships are inside. It will come from how many roll out the door, how many are stacked. Those are the only metrics that count in a race. Think about the old way. NASA builds the SLS rocket. It is a great rocket, but it is built in a serial line. That means one thing happens after another in a single row. The SLS has flown exactly once. It took over 10 years to reach that first flight. Starship has built and tested dozens of ships and boosters in just a few years. That pace gap is not getting smaller. It is getting wider every day. This matters because the facilities lock in how people behave. A slow facility produces slow results. Parallel facility like the gigabay produces parallel results. Here is another comparison to look at. Boeing's Starliner production uses traditional aerospace methods. They use clean rooms and slow integration. They have low build rates. That process delivered only a few tests over many years. Each capsule took a very long time to finish. The rework was very heavy. The gigabay is not that world. It is not slow or single unit. It is not a white glove lab. It is an industrial yard, and industrial is what you need if you want scale. The gigabay also changes the layout of the whole site. Vehicles built inside can roll out right next to the test stands. Shorter paths mean less risk. It means less traffic on the roads. It means fewer heavy lifts. That matters when the vehicles grow this large. A fully stacked Super Heavy can weigh more than 5,000 tons when it is full of fuel. Even when it is empty, it is a massive weight. Anytime you move it, there is a risk. Shorter moves are safer moves. That explains why the gigabay sits where it does. It anchors the production side of Starbase. It feeds the test stands. The test stands feed the pad. The pad feeds the flight, and the flight feeds refurbishment back to the gigabay. That closed loop is the ultimate goal. Here is the part most people miss. The gigabay is not just about the rockets, it is about the people who build them. 24 work cells mean 24 different teams. That means every team has clear ownership of their ship. They have clear metrics to meet. They have clear competition with the cell next to them. One cell's output can be compared to another. You can look at build times and defect. You can see how many hours they spent on rework. That internal scoreboard drives everyone to get better. Men respond to scoreboards. Teams respond to scoreboards. The gigabay makes that scoreboard visible to everyone. You can walk the top floor and see which teams are moving fast. You can see which teams are lagging behind. You can act on that information immediately. That is management leverage built into the steel. This also changes how people are trained. In a slow program, a worker might only see one rocket stack in their whole career. In the gigabay, they see one every week. They get more experience in a month than old engineers got in a decade. That builds a level of technical mastery that is hard to beat. It creates a culture where impossible is just a word for something that takes a little longer to bolt together. The gigabay is the physical proof of that culture. It is SpaceX putting their money where their designs are. They are betting that rockets will keep growing. They are betting that volume will be the most important thing in the future. Other companies may try to build taller bays later. They probably will. But timing is everything in a race. Being first to this scale gives you a head start that is hard to close. It allows you to make mistakes and fix them while others are still digging their first hole. Let's look at the strategic future. The goal is Mars. Elon Musk has talked about building 1,000 ships a year. That number sounds wild to most people. It only starts to look real when you see factories like this. The gigabay is the first of its kind. It proves the concept that you can build rockets like you build planes or trucks. If it works here in Texas, it will work in Florida. It might even work overseas one day. Each factory feeds a specific launch route. That is strategic positioning on a global scale. It is about controlling the flow of mass into orbit. Right now, most launch systems on Earth live on one coast or at one site. They have one weather pattern and one power grid. Here, the work is split up. The risk is split up. If a storm hits one site, the other keeps moving. That drops the time risk significantly. Inside each gigabay, the floor is not random. The cells sit like a machine. You have run shops before. You have seen how one broken machine can stop 20 men from working. You also know the relief when a second machine starts up. The noise changes and the pace gets steady. The stress drops because you have a backup. That feeling is what the gigabays are. They are competence built into steel. Now look at the competitive scoreboard again. If each site builds 50 vehicles a year, that is 100 total. If each vehicle flies 5 times a year, that is 500 launches. Even if they only do half of that, it is still 250 launches. No other nation is even close to those numbers. China might reach dozens of launches a year. Europe usually stays under 10. Russia is under 20. The gap is not closing, it is widening because of the factory. The building is the competitive edge. It is the machine that makes the bigger machines. It takes the lessons from every explosion and every delay and turns them into steel. It answers the problem of scale with scale itself. This building proves the shift from a test site to an industrial center is real. It shows who is ready for a world where rockets are common. Others are still building for a world where rockets are rare. Those two worlds cannot live together for long. One will replace the other. The gigabay stands because the next phase of spaceflight needs it. Once it is full and running, the pace of space will never feel the same again. The achievement here is not just the height of the roof, it is the output that it unlocks for the future. The competitive edge is not just how it looks on camera, it is the rhythm it enforces on the workforce. What comes next flows straight from this building. It is a future where building the rocket is no longer the hard part. The gigabay shows the direction, more ships, faster cycles, lower gaps. It turns the beach into an industrial powerhouse. It locks in a future where the sky is no longer a limit. It is just another place to do work. The gigabay shows that SpaceX is shifting from testing to output. By building a factory that can hold 24 ships at once, they have removed the physical limit on how fast they can fly. This building is a machine that will produce a fleet capable of reaching the Moon and Mars. It proves that the era of rare rockets is over, and the age of mass production has begun. Success now depends on the rhythm of the factory floor.